All right, so after our solution has cooled down and we added the sodium chloride, if you notice, it actually changed back to a somewhat creamy color. But this is because the sodium chloride has made it change colors back to somewhat of a creamy consistency. And the reason why we added the sodium chloride is to try to increase the difference in solubility between the aqueous and the organic layer. We will be adding some dichloromethane in just a little bit as soon as I add my solution to the separatory funnel. So I have a separatory funnel here, and this one holds about 250 milliliters of liquid. I have it attached to a ring stand, and I always like to double check that my stopcock is closed at the moment. Let me go ahead and add my solution. And it is important that we do use a glass graduated cylinder in this case. Dichloromethane has a tendency to react with plastics, and so, we're going to go ahead and use glass in this case. All right, so if you check it out, right now it looks like I have some bubbles happening in my solution. I'm going to cap my separatory funnel here and start my inversions. Every so often, I go ahead and vent the solution there, and that's to let out any carbon dioxide that has built up. And because of the compounds that we have in our tea solution, and the fact that we added calcium carbonate earlier, we could have built up a good amount of carbon dioxide in the solution. And so we want to ensure that we allow the gas out. So because of the saponins that are in the tea, we do have quite a bit of bubbling happening down here. This is known as emulsion. And emulsions, is where we're not getting separation of the two layers very well. Again, this is because of the saponins that are present in the tea compound. And so what I'm going to do here is gently tap and move my separatory funnel back and forth to help break up my bubbles. In the event that we can't break them up, the nice thing is that we will be adding some magnesium sulfate, which will help us remove all of these bubbles in just a bit. Okay, so I'm going to give it just a couple of taps here with my finger, see if that helps break up the bubbling. Okay, it's being a bit stubborn this time. Alright, well, we're going to go ahead and release the fluid, and we will let magnesium sulfate do its job. I'm going to release only the lower layer, and based on density, you would be able to tell me which solution is which. So one of these layers is made of water, the other layer is made of dichloromethane. But which is which? Density always has the answer. Okay. So if you notice here, we do have a little bit of that emulsion in the solution. When I add magnesium sulfate, that should get removed. Okay, so here we're using magnesium sulfate, and this is specifically anhydrous magnesium sulfate, which means that all the water molecules have been removed from this solid. Most of you will know magnesium sulfate in the form of Epsom salts, which is used for, soaking your feet or achy body parts and that sort of thing. But Epsom salts has water integrated into the crystals. If you notice here, this is very powdery, kind of like the calcium carbonate, which is showing us here that we have absolutely no water trapped in these crystals. I'm going to go ahead and measure 4 grams of the magnesium sulfate, and we'll add it to our emulsified liquid. Here is my liquid that I have with a little bit of emulsion. I'm going to go ahead and add my magnesium sulfate to my Erlenmeyer flask here. And I've added about half of my magnesium sulfate. If you notice here, I am collecting up the emulsification here, and it's turning solid. So, all right. Because this is exothermic, it's a little bit foggy and hard to see as some heat is being released. All right. I'm going to save the other half of my magnesium sulfate for our next liquid extraction. All right. We're going to action with another 25 milliliters of dichloromethane. we will repeat the inversions with the separatory funnel. And just like last time, I'm going to go ahead and vent, although we probably won't build up as much gas in this second round. Okay, so that should be good. Oh wow, we did build up quite a bit of emulsion again this time. Not a problem. We're going to go ahead and release our lower layer into our separatory funnel and let the magnesium sulfate do its work. Okay, there we go. Now if you notice, again my emulsion is pretty hefty, and so I'm going to go ahead and add magnesium sulfate again to help us completely capture all of that emulsion. Okay, and if you look very closely, there's some bubbling happening, a little bit of fizzing occurring in the solution. And go ahead and swirl. Go ahead and cap so I can swirl a little more vigorously. Okay. All right, so most of the emulsion has been captured. We're going to go ahead and let this sit for a couple of minutes, and we're going to do a third liquid extraction with our separatory funnel. Let's go ahead and do this third extraction. All right, so our last extraction with dichloromethane. So again, we have 25 milliliters of dichloromethane, which I'm adding into the separatory funnel. And liquid extractions are usually done about 3 times. 2 to 3 times is usually sufficient. This is our third run with dichloromethane. Okay, so again, let me remove it. Let's do a few inversions here. And a little bit of venting. Ooh, that was a loud one. All right, so one more. Okay, so I'm going to go ahead and place this again on the ring stand. And one last run of the liquid. Okay. So, I went ahead and measured 1 extra gram of magnesium sulfate, just in case we got more emulsion into our solution, which we did. So let me go ahead and add that magnesium sulfate. So, as I place it down, I notice I still have a little bit of emulsion floating at the top of the solution here. That means that I will need to add a little more magnesium sulfate to my container. Magnesium sulfate typically is not really measured. It's added to the solution basically until you see all of the emulsion gone. First I'm going to go ahead and eyeball about half a gram into my container here and go ahead and add it again to my solution. Okay, and if you watch closely, you see some fizzing occurring. Now, you know you've added enough magnesium sulfate when your solution is nice and clear and you can see some free-floating magnesium sulfate particles, which I do not see yet. So let me add just a little more solid. And so this will be about 6 grams total added so far, once I add all of this solid. Okay. If you notice on top the magnesium sulfate that hasn't reacted yet is nice and white. The stuff that has reacted is dark because of the, tannins in the tea solution. And this is what I'm looking for in my solution. I like to call this the snow globe effect, where you see some individual white magnesium sulfate salt crystals floating around in the solution. This is not the super snow globe you would typically see in a, item you can buy at one of those tourist stores, but yeah, it looks like we are getting some nice individual magnesium sulfate crystals floating around in the solution. We're going to go ahead and let this finish reacting for a couple minutes, and then we'll filter into our round bottom flask. Okay, so our solution has been sitting with the magnesium sulfate for a few minutes, and it's been absorbing any moisture, any water that is in the solution, so that we have just dichloromethane, in our liquid solution here. I'm going to go ahead and filter and into my round bottom flask. And in my funnel here, I have a small piece of cotton acting as my filter paper. Cotton can be used as a filtering device, as long as you ensure that it is, well anchored to the bottom of your container. Okay, so I'm going to go ahead and start pouring the solution in, and I'm going to be checking that our solid stays behind. Okay, so in the round bottom flask, I should be receiving only liquid. Our round bottom flask here has been pre-weighed, and it is completely dry, completely clean and completely dry. Go ahead and let a little bit of solid come towards the cotton here, and using a finger, I'm going to go ahead and gently press down, release any liquid. Never press down too hard, or you won't let solids through. All right. Next up, we are going to evaporate away our liquid and obtain our solid caffeine. All right, so this machine that you see is known as a rotary evaporator, and this machine will help us to evaporate the liquid from our round bottom flask and leave behind the solid caffeine that we are interested in. We have a couple of unique items here, and one of the most important pieces of glassware here is this item, which is known as a bump trap. In the event that any of our liquid comes through too quickly, we have a little disc of fruited glass here that will prevent any solids from shooting through, and we will also maintain the majority of the liquid down into the round bottom flask. The goal of this machine is to get our solution boiling on this side of the machine. It becomes vapor, comes through the tube, and on the other side of the machine, notice that it looks very, very cold. Inside of here we have what's known as a cold finger, and we have some dry ice and isopropanol. That will make this particular site extremely cold. As our vapor goes through and encounters the cold finger, it will recondense to form a liquid, and we will collect it here in this round bottom flask at the bottom. Okay, this allows us to do a couple of things. Dichloromethane is not good for the environment, and we should try to prevent its leaching into the atmosphere. This is because it's a chlorinated hydrocarbon, which means that it can possibly react with molecules in the air, especially ozone. So we want to prevent that. The other bonus to this is that we'll be able to collect the solution and possibly even recycle that liquid. So let's go ahead and get this machine going. And I'll go ahead and attach my round bottom flask first and clamp it with a clip. All right. Attached to the machine, we have a vacuum pump, and because the vacuum pump is extremely loud, I'm going to have to speak even louder. All right. Okay, so we got quite a bit of physics going on here. And if you notice on this side, my liquid is already starting to boil. Okay, so let me go ahead and get some rotations going here. Okay. And I will start to bring my liquid down towards the water. Alright, you can see that the liquid is boiling pretty vigorously in the round bottom flask here. And I'm going to go ahead and wipe off the fog. But you can see that we are already collecting liquid here on the other side as it's touching against the cold finger. It's dripping down, and we do see a little bit of liquid collecting here in the receiver flask. Again, the goal of this machine is to evaporate only the liquid and hopefully keep any solids in the original round bottom flask. This is where we should find our caffeine.